Hello, everyone. I'm very happy to be here. My name is Pavel Shigelski, and as Valentina already mentioned, I will be the moderator of this Android track. Please, if you have any problems, just ping me in the chat or any other try. So we will try to help you to handle that. I'm so excited to be here. It's a bit pity that I can't see you all the whole audience here, but just only virtual. But yeah, however, it has some benefits. We can meet together with top level speakers, experts around the world, and so they can share their experience and vision. And I'm very happy to introduce our first speaker. It's Igor. Hello, Igor.
Hi, Paolo.
Yeah, how are you? How is your day?
Oh, very well. Thank you very much.
Yeah, everything is fine, right?
Yeah.
So yeah, I don't want to spend anything. So I will leave you alone here, and I will mute so you can present your session. Okay. So are you ready to rock the stage?
Yeah, I'm ready. I'm ready.
Yeah. By the way, I didn't mention, like after the session, we will have a Q&A session where we will ask, we will listen to the questions, or I will ask you the questions, so we can hear the answers. Okay, great. So yeah, I will mute and leave you alone with the presentation. Thank you.
Thank you. Hello, folks. So my name is Igor Wojda, and I'm Android developer advocate at Vonage. We make communication API. So if your application needs to send a SMS message, WhatsApp message, audio call, video call, or some kind of verification code, like you get the idea. This is us. So today we'll be talking about modern projects and the way how we should structure the project in a way where it allows us to easily grow, maintain, test, and scale over time and make our life easier as a developer. So before we do that, let's take one step back. So becoming a developer, right? So everybody at day zero probably started with our first Hello World program. Then we moved somewhere into first variable. We defined our first methods. Then we defined our first class. Then maybe first module. And then things became a little bit more complicated. So the question is, why developing quality software takes time, or why it's not so easy to to remove all the bugs from software, or why the software is so hard or difficult to develop and test most of all. And the answer for that is actually a single word: the complexity. So we have multiple kinds of complexity. We will chat about two of them today. So first of all is complexity at application level. So what does it mean exactly? So let's look at the simple example. So imagine we have application that contains single text input field and single button that verifies this input. So this can be mobile application, web application, desktop app, any kind of app. So if we take a look at possible inputs, right, we have 26 small lowercase characters, 26 uppercase characters, 10 digits, and special characters. Of course, there are many more, but let's say 10 just to keep things simple. So in total, this gives us like 72 characters that user can enter into this field, right? So when user enters single character, we have 72 permutations, right? If our user enter 2 characters, this gives us over 5,000 permutations. If our user will enter 3 characters, this gives us a lot more. So the idea here is that it's very difficult to test those applications because number of all possible scenarios that we could test grows extremely quickly, and this is a very simple example, and yet it would be very hard to test it all with 10 or 12 characters. So with certain data types, we learn how to deal with, right? So some data types, like for example, banking card. They have a number that is not like a random set of digits, but it's also the number that has some kind of checksum within it. So it means that we can perform quick validation based on very simple check, just to make sure that maybe user didn't accidentally make a mistake. However, some other data types became even more complex than that. So let me show you. So let's say we want to validate email, right? Everybody uses email, like it's main form of communication nowadays. Like email address format is simple, right? And this is when things go complicated. It's not simple. So this is actually Java regular expression to verify correctness of the email address itself. And the PHP version, I think, is five times longer. And this works only in 99.99 cases. So even with popular data formats and popular things, it's not always that straightforward to verify them. That's why we usually would use some kind of third-party library and hope for the best. Another example of more complex data type that is hard to verify is usually date and time. So when you look at date and times, right, you have a year, you have a month, like how difficult can it be? But actually, when you read a bit more about it, you realize that in some countries there are non-existing years because there was a war and nobody counted those days, or like February had 30 days at some point, etc., etc. So there are always some kind of exceptions that will make our life as a developer more difficult. So another kind of complexity is a software project complexity. So this is more kind of overall big picture view. So moving away from our Hello World application, from methods, classes, and stuff, we need to consider multiple aspects of programming, of creating a software project. So, for example, we need to take care about code style, right? So, what kind of formatting are we using? Do we put spaces after methods or not? Do we put brackets like in the same line as if statement or in the other line? We have code quality, right? So how complex is our code? So let's say our methods are simple. They take like 10 lines of code, so they have like 50. How many arguments or parameters our class has? Like, does it have like 3, which is fine, or does it have 15, which is probably too complex? Then we need to care about correctness, which basically means that does our code do what it's supposed to do? Then we have a framework and libraries where they help us to solve certain problems, but we still need to keep them up to date and make sure that we are using the correct ones, especially without any bugs that may impact our application. Then we have architecture. So it's a way, how would we structure our code in our application in a way where it will be, easy to maintain, easy to test, easy to scale, easy to develop over a few years in the future. Then we have programming languages, right? So for Android, for a long time it was Java. Now recently there's a trend to move to Kotlin, of course, because it's better. But on top of that, when you think of programming languages, we still have more. We have XML to define views. We have Groovy or Kotlin script nowadays to define build scripts. We sometimes use Markdown maybe for some README files, and there are some configuration files, like for example for DexGuard that has own syntax, or maybe languages for CI, where usually YAML is used. So even for simple Android project, we have so many languages and technologies to think about as a developer. So then we need to worry about problems like networking. Like on mobile phone, we can never trust the network, delays, reliability. So we need to deal with that as a developers, because at the end, user wants just a seamless experience where the app just works, whatever it means, under the hood. Then we have a data storage where we need to think, how would we store the data? Would we use local database, maybe some kind of Firebase online database, maybe shared preferences, or like how would we store the data, how we cache them, how we keep them up to date, how we make sure this actually works. Then we need to think about UI, right, and UX, which is how user interacts with our app. Like, is it obvious how to use the app? Is it easy to use? What are our users are struggling with? So we need to understand the flow of the application to make sure that for user, again, it just works. It is just seamless. Then we need to worry about users that are not fully accessible. So some people may have some problem with sites, like in terms of they don't see certain colors, or they see only large fonts. So our application need to takes those things into consideration, right? Or maybe there is a button that is image, that's the image for normal user, it would be fine. But for our user who is disabled, like let's say the user cannot see, this image means nothing. So our accessibility reader, like a talkback, needs to actually read the text, and we need to provide that, right? Most of the stuff is handled by Android framework, but still, like, some work needs to be done around it, and needs to be properly tested to make sure this works as expected. Then we need to think about different Android versions where, like, for example, for iOS, usually you need 2 or 3 devices, and this is it. Like for Android, we probably need like 50 with different manufacturers and different Android versions, and probably at least 5 or 6 bags. Then we have those devices where most of the things are working everywhere in the same way, but sometimes we have those device-specific problems. So I remember the case in our company where we realized that in one of the Samsung devices, we used Android string with white color, which was hard-coded. And on this one device, the white color wasn't white. So we used like pre-existing string, where we assumed this like air.id.white means white color, but it wasn't. And things like this will come out one way or another. Then, of course, we need to release our application. So we need to think, how we release this to our customers, even to our testers or product owners, think about production channel or beta channels. So we need to think about how will we do that. Then we have build scripts, right, that maybe obfuscate our code. Maybe they provide multiple versions of applications for different clients. So there is also some maintenance and some logic around it. Then sometimes we need to care about documentation, mostly in open source projects, right, where we want to keep things up to date, document our API, maybe generate Java documentation. Then we have version control, which is nowadays mostly Git and a GitHub together, or GitLab, or any big bucket, and few others. So we need to understand, how this works, and of course, like making a commit with single message, it's easy, but then comes things like conflict resolution, or things like, you have some connected modules which you update in different ways, or some unexpected things happen. So it's not usually that straightforward, especially in the larger projects. On top of that, we need to think about the security, right? So is our application secure? For example, like is the code obfuscated, right? Maybe it's sensitive code, and we need to make sure it is, right? Do we keep any private keys within application, which we shouldn't? Do you always use HTTPS connection instead of HTTP, right? And things like that. Then we have some external tools, I would say, around the project, right? Issue trackers with our backlog, like Jira or Redmine, where we basically communicate with our team, on things that we'll be doing, tracking some bugs and moving forward. Then we work with our IDE, Android, which is Android Studio for most of us. And then, like, even IDE, right? It's just IDE, but there is a lot of shortcuts to master. There are some things that are not obvious at the first glance. Sometimes you have weird errors that you need to deal with. And then we have plugins that makes our life easier. So it's also handy to know a few of them. Then we have terminal and command line, which allows us to do more advanced things that IDE or UI tools doesn't really allow to. So we need to master at least, have knowledge about this as well. And then on top of that, like at the end, comes all the soft skills, right? Like learning skills, leadership, management, resolving conflicts, and organizing teams, prioritizing works, and things like that. So there is a lot of things to think about as a developer when you look at the whole picture. Definitely much more than Hello World. And on top of that, one thing that is constant is a change. So everything will change, like nothing stays the same. customer requirements will evolve, libraries will evolve, OS systems will change, new devices will appear, there new stuff will be added to Kotlin, like recently coroutines. Google will give us best practices, like recently introducing Jetpack, some architectural components. So all of this is a major impact on our work. So fortunately, not everything is lost. We have tools that at our disposal that allows us to deal with some of this complexity. Unfortunately, not all of it, but allows to remove a lot of overhead from our mind. So first tool that everybody knows, but not everybody uses, are IDE hints. So this is very useful because most of those hints are really helpful and they show you how to write easier code, especially in more complex projects or more complex contexts where you just don't see it in the first glance. So what is important about it that they are not visible during PR reviews, right? Pull request reviews at later stages. So it's your responsibility as a developer not only to address them, but first of all, just make it a habit. Each time you see it in the project, just click this command Alt Enter, I think, or Command Enter in IDE, and basically it will show you the code hint and just apply it. Spend maybe a few seconds to understand what happened and learn a better way of writing your code, but just make it a habit because only you as a developer can fix it. Like for example here, right? We have simple hint that allows us to introduce different subject of one statement. Most important tool are linters. So linters are tools that analyze our code without running it. So looking at very high levels, how linters are working, we have application source files. Then those files are taken into lintool, and then the linter produces some kind of result. So usually a linter focus on single aspect of our project. We'll talk about a few now. So first is of course the Android lint, right? So this one is a bit different than others because usually linters are run from command line. This one has also Android Studio integration, so we can run it from Android Studio as well and have nicer UI. So now let's take a look how different linters check different aspects of our projects, right? So what are they responsible for and why we need few of them? So Android lint focuses on Android related things, Android platform related things, right? So we may have things like correctness, right? Is the resource used or not? Or security I mentioned, are we using HTTP? Maybe some usability things like does our image in a button has a description for accessibility. Some performance like absolute layout, maybe too many params, too many our vector drawers that may be too complex. So everything around Android. Then we have two other linters that are verifying code formatting. So there are two because for Kotlin we use KTlint and usually Kotlin Gradle plugin, and for Java we would use checkstyle. So for example, we have this missing validation where the linter detected that there is no space, right? So it will show us some kind of warning or error message, and of course we can easily fix it. So the biggest difference between KTlint and checkstyle is that checkstyle give you massive configuration. So you can decide, how would you put your brackets, where would you put empty line, how many parameters should, no parameters not, but basically it allows you to configure everything. So versus checkstyle versus KTlint is configuration free. So it means that we will not have hour-long or 2-hour-long meetings in a team where would we put a space or where we put new line. It's just there, take it or leave it. And the good thing is that it combines Android coding conventions and Kotlin coding style. So to take like kind of the best of the both worlds. So this linter will tell you about things like missing empty line, missing space after declaration, or like line length is too long. Basically everything regarding like code formatting in a visual sense. So then we have a detect. So detect deals with complexity. So what I mean by that is basically it tells us that, for example, our class has too many parameters in the constructor, like here, or maybe we have some kind of unused member, or maybe we have a magic number in our code. Maybe we have too many return statements in our method. Maybe if statement is too complex, has too many blocks, or maybe we somewhere ignored the return value or have unused safecasts. So basically everything that doesn't really look right in a code from complexity or code correctness perspective. Next one is a spell checker, actually. So this is useful, especially if we, like, for example, in Vonage, we maintain documentation for our developers for library. And trust me, it's so easy to make a spelling typo, like, especially if you're not native English speaker. So this one basically goes through all Markdown files and verify the correctness of the text. And I'm not sure if you noticed, but this spell check is also misspelled. Those are two words, not one. So things like that are easy to miss will be caught by some kind of spell checker. Then we have online tools. So those tools are mostly useful for open source projects. So what those tools do, they're quite easy to set up, and they take your project and analyze it like using their own set of rules. And often I found that they find things that previous linters are missing. So if it's open source project, it's very good to have them. Like, why not? You just configure them once and then they are there. And on top of that, they give you some kind of overall code quality score, usually from 1 to 5, which is also nice to have and show people that your code meets some quality standards. Then we have tests. So tests actually are quite massive subjects, and there are many ways to do this. So we will not go deep into that. But what I want to tell you is, first of all, we know this Android testing perspective pyramid. This is something that Google officially recommends to test Android application. So what I want to point here, that this is not only way of thinking about tests. So there are another alternative classification of our tests. So, for example, we can have functional, non-functional test, or white box, black box test. So, like, you need to understand that testing has many ways to look at it, and the more complex the project became, the more important those alternative things are. So, the biggest takeaways from test, I would say, you should always test your project, and like never push for 100% coverage, because this is number that basically means nothing. Like, low coverage means that probably you have a problem in your project. High coverage means nothing. You need to create like simple human readable tests, and and one important thing is that you can duplicate code in your test. Like in production code, you shouldn't do that. In tests, it's a different story, because we favor readability over duplication here. So now, to help us with our work and to create this modular, scalable, maintainable, and testable project, we have some Gradle plugins that can help with that, with certain parts of processes. So first one is Gradle Play Publisher. So this plugin actually will help us to automate our release process, right? So it will help us to publish our application to the Play Store, like not only to release channel, but also to our testing channel. So, for example, each time we make a merged or master or main branch nowadays, we will basically release new version that will be automatically uploaded. And this is the tool to do that with actually single command. document and some config, it's achievable. Then we have Gradle dependency log plugin. So this plugin basically allows us to deal with dependencies. So we have two kinds of dependencies in Gradle. This one is called fixed because number of the library is fixed. Another one is dynamic dependency because number of version of the library is not fixed. So what Gradle log plugin does is basically allows us to use dynamic dependency in a kind of static way. So when we use only dynamic dependencies, always let's say the newest version of the library is downloaded, or in this case, the newest patch version. So if we do that and we want to check out the project, let's say from 2 months ago, 3 months ago, and make a build, this will be different build if external libraries has changed. So this plugin allows us to keep those dynamic versions, but at the same time, it overrides Gradle behavior where we need to actually run a single command to say, okay, fix our projects to those dependencies. And this will generate some kind of config file that will be in our project folder. So this allows us to make sure that we update all the dependencies in one command, and we do this only when we want, but also at the same time, when we check out projects from 3 months ago, and we compile it, the resulted build will be the same. Then you have architecture, which is another big subject. So to keep it simple, let's just make sure to use feature modules, and within those feature modules, like define some kind of distinct layers to separate your code. This is only example. It doesn't really. It's not the only way to do that in terms of layers, but just be consistent whatever you do in the whole project, and also across all the modules, because it's important to know that like you are not the only one who's working on the project. Like whole team should understand what you're doing. And if you open one, let's say a view model class, right, in one feature module, and then you open another, you should just look at it and understand what's going on. Like every class should be consistent. Then we have Arc Unit framework, a framework linter that is a little bit that needs a little bit love from Android community, because I had some problems running it recently. But this one allows you to verify your application architecture. So imagine you can check whatever certain class, let's say services class, are in our service package, or you can define like layers for your feature modules, and then define some kind of checks to make sure that, like for example, domain layer doesn't access anything from data and presentation layer. This is easy to achieve if you split those layers into different modules in Android Studio, because you can define module dependencies, but in practice, I would not recommend that. So we need some kind of external check. So let's talk about automation. We have a lot of tools, right? But they are useless if they are not used. And to make them use, we need to automate this process. So let's consider simple high level of CI flow. So we have a code change, then we push our code to repository, and then we run some kind of checks. So we have our GitHub. So there are multiple CIs, right? Say Jenkins, Travis, TeamCity, and all of that. Like I will show you a simple example on the GitHub Actions, which is recent addition to GitHub, and it's also free for open source projects. So it's quite easy to do and set up. I think it's the easiest CI to set up. You just put a few files in workflows, GitHub workflows folder. So let's define simple action. So going back, so we have those folders in a GitHub called, so in our project we have folder .github and then .workflows, and every file that we put there will be run as a workflow. So to define simple workflow, we need a few things. We need a name, we need some triggers. So when it's run, like in this case, like when PR is opened, or when PR is opened. Then we have some setup steps. So like what kind of operating system we'll use. Do we want to fail fast? Then some kind of environment we want to install on this our Ubuntu image, like Java 1.8, and some some actions regarding the project checkout. And then actual tasks that we want to run. And then some kind of artifact. So each linter produces result or artifact, which is usually the report where we contain like is XML or HTML with list of the checks that passed and failed. And this is it. You put this file in one folder, and this will start working automatically with every PR. So when we run our PR, we'll see something like that, and you will have a list of all those checks that passed and all those checks that failed. And this is actually the way to go, because there is a lot of tools to consider, and automation, like just to make sure that they are run with every PR, just makes sure that our code quality stays high. So let's talk about like flow, like how this fits into modern development perspective. So let's say we want to fix a bug in our project. So we check out the code, then we create new branch in our project, in our local checkout repository. Then we will fix the bug in the code. Then we will push changes and create remote branch and create the PR, of course. And then our CI will run. So let's go take a look at into what's happening within the CI. So for example, we may have multiple steps in our process. So first always is code checkout, right? We need to know what are we checking. Then in second step, we can run all the linters that we have. Of course, we can make a decision whatever or not we want to fail. So for example, do we want to fail if one of the linters is failing, or do we want to fail the CI when CI is failing at certain steps? So for example, here I would fail when one of those linters are failing, because I want to have a big picture, right? I want to see instantly which one is failing to know what I need to fix. And then if linters will pass, we may have a step where we build our release and debug versions. It's worth to build two, especially if you have different dependencies for release and debug, because usually when we're testing locally, we run debug version, so everything works, but release may also fail from one reason or another. And then we may, let's say, publish this. If release builds are fine, we may publish it to release channel, or probably to some kind of beta channel for our testers, and then notify our testers about the version of the software. So going back to our big bug fix flow, then if all the checks are fine, we would have some kind of code review. So we would say to our team members, guys or folks, take a look at those PR and tell me what should I improve or what should I change. Then if everything is fine and everybody is happy and CI is happy, we'll merge our branch, let's say to main branch. And then we would do some kind of production release in manual or automatic way. So this is very high level picture how nowadays we can help ourselves with linters and automatic tools in our Android project. And as you've seen already, like this is quite complex process. So trust me, without those checks that run on each PR, it's extremely easy to miss something. Think about, like people change in a team, right? One experienced person will leave, and maybe a junior or new person will come, and this person will usually not have all the knowledge in the project. So even just guarding us from making simple mistakes, linters are very, very good first level kind of way to do that. So main takeaways from this talk for you is that whatever you decide in your code base, like however you want to structure your project, just make it consistent. I mentioned this already, but just to clarify, like if you again open one fragment class and then open another in different module on different feature, just make sure they are the same. They follow the same way of doing things. If you are testing things, just keep them simple and make them readable. So like don't create like 50 lines of tests, like don't put 10 assertions in a test. Don't make tests like long in terms of like number of lines, but also line length, and use, like naming convention that is descriptive and easy to understand. Personally, I just prefer like simple English, when user open the screen, just show button, verify. Just the easier to understand, the better. Then of course, use the tools that will help you to verify your project correctness. And then think about your architecture, especially if the project will be maintained for a long time, because like bad architectural decision in the beginning will cost you a lot of effort and then energy later. So it's always good to have a bigger picture in mind, like longer project life cycle. And of course, automate releases if you if you can, because also like a release usually it's not one step process, it takes some steps, so it's easy it's easy to mess it up. So I have for you some resources to take a look at it. I will share those slides on my Twitter, so don't worry. It will be on the next slide. So first one is Android Showcase. This is my personal project on the GitHub. I just started to work open source project to demonstrate architecture, and by accident it got a few dozen stars. So take a look at it. There are also references to other projects there. You have links to the linters that we discussed here, and then some GitHub actions and other useful things. So thank you very much for your attention. And you can follow me on Twitter to get this presentation and more interesting stuff. So now I believe there is a time for questions.
Yeah, that's great. It was a great topic, great talk. Thank you, Igor, very much. Yeah, you covered all the details about the good practices that we should use during our development. That's great. We have only 4 minutes for the questions. As I see from the chat, there are not so many questions for now, but maybe later they will appear. I will just remind you that you can always write Igor in Twitter. You can reach him very quickly, and it doesn't matter. Or you can join the room after the session where you can ask your questions, right?
Yeah, Twitter or Kotlin Slack, I think those are good to find me.
Yeah, great. But I have a question for you, a personal question. What do you think? Like, best practices and engineering practices are a very good thing. We always should remember them and should follow them because it brings a good in the future. In the long run, you will receive a benefits out of it, right? But what do you think if, for example, I have an application like basic application, like 2 screens and not more, and I don't think that I will later develop it and add new features. What do you think, whether we need to spend some time on following all these engineering practices in those applications, or it mostly applicable to huge projects, big projects, and so on? What's your opinion on that?
Definitely, the bigger the project, the more benefit you will have, right? But even setting up this, like, you always need to find the balance, right? How much time you want to spend and what is the benefit. So you always analyze project by project basis. Probably for the project you describe, I wouldn't do that, like from the project perspective. However, like if you just set it up once, you will just learn something, right? This is what I did with my open source projects, where I just created a simple project with 2 screens, which usually all the recruiters for Android position wants, like a screen with list of items, like list of products in the shop and item details. And this simple project, like with 2 screens, like 300 commits later, my to-do list has 100 things to do still. So I learned a lot just to set this stuff up on smaller project. It's a very good way to practice things. And now when I move into bigger projects, I just know these things. So it's much easier for me. So it's I would say if it's only for this small project, no. But if you want to learn something, definitely, why not?
Yeah, definitely agree with you totally. The good practice is when you do it on your own and try it on your own. Yes, as usual. But later then you can take this knowledge and on any new company and adopt it in a new company or anywhere. Okay, and one last question before we leave here, like from my side again. What do you think about you covered lots of different engineering practices. Do you have anything else in your company? For example, just 1 or 2 practice, one more. For example, maybe you have a kind of a guideline how to create a pull request or how to create a good commit message or anything else.
Mm-hmm. So we have a guidelines for, I think, good commit message. But this is again like another quite complex topic. So they like just keep them descriptive, keep them simple, and you make sure that when someone reads it, like he understands. All right. And on top of that, like when you open those PRs, just like make sure that you would actually describe like what was the intention, what you wanted to do. because then when someone is reviewing this, he has more context, so it's easier for him to review, but also like it's easier for him to point some kind of mistakes or better solution to the problem sometimes.
Yeah. Great, thank you very much. I don't see any more questions from the audience. I think that everybody gets the whole idea, and I hope that everyone will follow the rules that Igor just mentioned and shared with us. So thank you very much, Igor. I think that we will leave right now, and I will end this session. And then, yeah. By the way, I'm looking forward to the next session from Fedor, so you can join as well.
Me too, of course.
Yeah.
Okay. Thanks.
Thank you.